Hi students, Mr. Rich here. I'm going to show you how to work matrix problems on the ACT exam, so let's get started. Let's look at this first problem and use it to explain what is a matrix. A matrix is numbers that are enclosed in between two square brackets like we have in this problem. Also with matrices, we classify them according to how many rows and how many columns they have. This first matrix here that I'm looking at, as you can see, has 2 rows and it has 2 columns of numbers. And so therefore we call this a 2 by 2 matrix. That's because we use the number of rows by the number of columns. That means that this matrix is also 2 by 2, and so is this one on the other side of the equal sign, 2 by 2. And if I'm going to add 2 matrices together, they have to be of the same dimension so that I could add the corresponding elements within the matrix. And this would also work if it was subtraction. But here I'm adding the 2 matrices, so that means that 5 plus A has to be equal to the number 10. So I would say 5 plus A is equal to 10. Also, I would see here that this number 12 corresponds to that number B, and so 12 plus B is equal to 4. I can solve both of these equations. This would be A has to be equal to 2. A is equal to 5 actually, right? 10 minus 5. And this one I would solve by subtracting 12 on both sides, and that would give me B is equal to negative 8. So therefore, what they're asking me to solve for here is A times B, and that would be 5 times negative 8, or a negative 40, and we've got our first answer. So before we leave this problem, let me just point out here that if I'm going to be adding or subtracting matrices, they have to be of the same dimension, and then I would add or subtract the corresponding elements in front of or inside of each one of the matrices. Let's go to another problem. In this problem, again, I'm adding 2 matrices together. It says which of the following matrices is equal to, and then I would just simply build a matrix that is going to consist of the addition, since I'm adding, the addition of the corresponding elements. 9 plus negative 6 would be a 3, 2 plus 8 would be a 10, negative 4 and 7 ends up being a 3, and 1 plus 6 is a 7. So I look for that matrix 3, 10, 3, 7, and here we go. That's our answer, H. Here's another matrix problem where I am subtracting instead of adding here, but very similarly what I would be doing here is subtracting the corresponding elements from each one of the 2 matrices. That means that my matrix, when I do this subtraction, would be 10 minus a negative 9. That would be 19. Now, I'm taking a glance at my answers, and I'm pretty sure that my answer is going to be K. But let's go ahead and finish this out. It's the only one that has a 19 in that first spot. Negative 13 minus a negative 17, that would be negative 13 plus 17, or a 4. Negative 8 minus negative 8 would be negative 8 plus 8, because the 2 negatives would cancel. And then 11 minus 14 is a negative 3, and so there's my answer. The next example that we have requires us to do some algebraic multiplication. So this says the 2 by 2 matrices A and B below are related to matrix C by the equation C is equal to 2A minus 3B. This equation that they want us to use is really telling us that I need to take the A matrix and multiply it by 2, and then take the B matrix and multiply it by a negative 3, and then combine those together into one matrix. Now, what does this mean to multiply a matrix by a number? Well, that would mean that I'm going to take 2 times this entire matrix A. It would look like this. And even if you didn't know anything about matrices, you might assume that what you would do is to take this 2 multiplication and distribute it to each of those 4 items or elements inside the brackets. And if you assumed that, you would be correct. And I'm going to then say that this is minus 3 times negative 4, 5, 2, and 1. When I distribute the 2, I'm going to get a matrix that would be like this, 6, 10, negative 4, and 2. And then what I'm going to do here is I'm going to leave this as a minus and then distribute a positive 3. So this would be a negative 12, this would be a 15, a 6, and a 3 when I distribute that 3 multiplication to all of the elements inside the matrix. Now I'm going to do matrix subtraction. These are both 2 by 2 matrices, so I can certainly subtract them, and I would do that by subtracting their corresponding elements. 6 minus a negative 12 would give me a positive 18. So when I'm looking at my answers, it looks like F is going to be my answer. It's the only one that has an 18 in that spot. But I'm going to go ahead and finish this out. 10 minus 15 would be a negative 5. Negative 4 minus another 6 would be a negative 10. And then 2 minus 3 would be a negative 1. And sure enough, that's our matrix F. And stay around to the end of the video because I am going to show you a problem that involves matrices inside of a word problem so that you actually have to know what the numbers represent inside the matrix. This next problem here is talking about a determinant of a matrix. Now, a determinant of a matrix is something that you really would not know what it is unless you had learned something about matrices in your math classes. And oftentimes when they give you a determinant problem on an ACT exam, they'll actually give you the formula that I'm about to show you as to how you would determine the determinant of the matrix. But in this case, they're not. This was an actual test. And in this case, you would have had to know how to actually find a determinant. So if you're asked to find the determinant of a matrix, and this is a 2 by 2 matrix, they would never ask you to do a determinant of something larger than that. But to do a determinant of a 2 by 2 matrix, what you do is you take the diagonal multipliers, you take 10 times 12, and then you do subtraction on the other diagonal multiplication. And this then becomes the determinant of the matrix. This would be 120 minus 160, and you get an answer of negative 40, and there's our answer F. Here's our next problem. This says that the table below shows the numbers of rows and columns in each of 5 matrices. For distinct values of k, m, and n, which of the following matrix products is not possible? Well, in order for you to figure this problem out, you have to know something about matrix multiplication. That is, when you're going to multiply 2 matrices together. The only way that you can multiply 2 matrices together is if the number of columns in the first matrix matches the number of rows in the second matrix. Here's what I mean by that. If I had a matrix and I wanted to do that matrix multiplication, this matrix here is a 2 by 2 matrix, 2 rows, 2 columns. This matrix is a 2 by 3 matrix, 2 by 3. So long as I have a match between the number of columns of the first and the rows of the second, I can do the multiplication. In other words, this matrix here could have been a 2 by anything. This could have been a 2 by 5 matrix, and I still could have done the multiplication of those 2 matrices. Now, what would the dimensions be for that matrix after I did the multiplication? Well, that would yield a 2 by 5 matrix. In other words, the matrix that you get after you multiply will be the number of rows of the first one, and the number of columns in your product will be the number of columns in the second matrix. Well, if we apply this idea here, this means that if I'm going to multiply E times D, well, here's matrix E. It's an N by M, and matrix D is an M by K. But you can see that I do have a match between the number of columns of the first one and the number of rows of the second one. So that can't be my answer because that matrix product is possible. D times C. D is an M by K, and C is a K by N. And again, I have a match right here. So that would not be my answer. That is a permissible matrix product. It turns out that K is the one that will not work because A is an M by N, and C is a K by N. I cannot take an M by N matrix and multiply that by a K by N. because these two do not match. And so my answer here ends up being K. Now, do you need to actually know how to do matrix multiplication? That's the question. On very few ACT tests have I seen them actually require you to figure out what the product is of two matrices. I have seen many tests where they ask you whether two matrices are permissible to be multiplied by this rule of being a match between the columns of the first and the rows of the second. But to actually do the multiplication, that's another matter. So here's a matrix problem that actually requires us to do matrix multiplication. Let's first confirm that we could even do matrix multiplication, that it is permissible. This is a 1 by 2 matrix. Its dimensions for matrix X, its dimensions are 1 by 2. It's got one row and two columns. And this matrix Y is a 2 by 1. It's got two rows of numbers, but only one column. And because I do have a match between the number of columns in the first matrix, matrix X, and it matches with the number of rows in the second matrix, matrix Y, I could then do the multiplication and it would give me a 1 by 1 matrix as an answer. And sure enough, when we look at our answers, they are 1 by 1 matrices. It's a single number. So the question becomes, how would I actually do the matrix multiplication? Well, what we do in matrix multiplication is we take each one of the rows of our first matrix and we multiply each one of the elements of that row by the corresponding elements in the first column. So that means that my result here is going to look like this. I'm going to take this -1 times -2, and I would add that to the product of the 0 and the -1. And this becomes -2 plus 0, or it gives me -2. That is my matrix, and there is my answer, C. Now, I can honestly say this, of many ACT exams that I've looked at, this is the only matrix exam that I've seen in the last 5 years where I actually have to do matrix multiplication. I could be wrong, maybe I've missed it along the way, but that's what I've seen. So I wouldn't worry about this too much, and I certainly wouldn't expect them to give you a matrix multiplication that would be any more complicated than a 1 by 2 times a 2 by 1. Just remember that you're going to multiply the first element of this row times the first element of that column, and then add to that, right? It's always going to be an addition here, this second element in the first row times the second element in the first column, and then that's going to be a 1 by 1, and there you go. For our last video, we're going to see how we would use matrices to solve a word problem. Here we have a 500 square mile national park in Kenya that has large and small protected animals. The number of large protected animals at the beginning of 2014 is given in the table below. This table has 6 large animals, and it gives the respective number of animals at the national park. Question 43 says that in this park, the average number of gallons of water consumed per day by each elephant, lion, and giraffe is 55 and 10 respectively. These are gallons of water consumed per day by each of those 3 animals. Over here, I see that I have elephants, I have lions, and I have giraffes. I've got the number of each one of those animals, and I know how many gallons of water on average each one of those animals is drinking every single day. The question says, which of the following matrix products would yield the average total number of gallons of water consumed per day by all of the elephants, lions, and giraffes in the park? This means that I would have to go and calculate how much water the elephants are consuming, the lions, and the giraffes, and add those together. Now, how would I do this? If I wasn't using matrices and they weren't forcing me to look at this as a matrix problem, then what I would do is I would take the number of elephants that I have, 600, and I would multiply that by the average number of gallons of water that each one of them is consuming, which according to this is 50. So I would multiply that and I would get 30,000 gallons. For the lions, there's 200 lions, and on average, these lions are consuming 5 gallons per day. Of my 800 giraffes, they are consuming 10 gallons per day. And I would do these multiplications, and then I would add all of those together to get one number that would represent the total number of gallons of water on average consumed per day by those three animals. Now, how then do I find the right matrix that will actually do this calculation? Well, remember when we're talking about matrix multiplication, to get the size of the matrix that you get from the multiplication, you would consider the dimensions of each one of the matrices. So in answer A, I have a 1 row by 3 column matrix, and I'm going to multiply that by a 3 row by 1 column matrix. I can do the multiplication because I do have a match between the columns of the first and the rows of the second. And the answer to that matrix multiplication would be a 1 by 1 matrix, which is what I would want, right? A 1 by 1 matrix is a singular number. And so both A and B would yield a 1 by 1 matrix, the total number of gallons that are consumed by the three animals. And remember what we also saw, that when we do matrix multiplication here, I would take this row and multiply it by the respective column. In other words, the 600 would be multiplied by the 50, and I would add to that the 200 times the 5, the middle number, and I would add to that 800 times the 10. And I could do that for both A and B. Now C, D, and E, answer C is a 3 row by 1 column, and this is a 1 column by 3 row. I can do the multiplication for sure because it's a match between the columns of the first and the rows of the second, but the problem is that this would give me a 3 by 3 matrix, which is not at all what I want. I want a singular number in my matrix to represent the total gallons for all three animals combined. So that tells me if this multiplication gives me a 3 by 3, no good. This one as well, I can't even do this matrix multiplication for answer E. I cannot take a 3 row by 1 matrix and multiply it by a 3 row by 1 matrix. I do not have a match between the columns and the rows of the first and the second matrices, so it's not even an option. So the only thing that I have to check is to make sure between A and B, which one has these elements in the right order. So my elephants are going elephants, lions, giraffes, right? Elephants, lions, and giraffes. And the gallons of water for each goes 55 and 10. So there you go. There's my elephant, lion, and giraffe gallons per day. So that is answer A. Answer B just simply has the 200 and 800 in the wrong order. So there you go. That's it. I have answer A. Okay, students, that's it for matrices. I hope this was helpful. If you did learn something in this video and you found it useful, if you would hit the like button, I would appreciate it. And also, if you want to subscribe to my YouTube channel, do that as well, as I will be posting content throughout the summer and into the fall when school gets started. Thanks for watching, and I will see you next time.